There we go. All right. So today we're going to be learning about queries and joins. Um, and this is really sort of the next step. We've learned the basics of what a relational database is, how to create tables, and how to set up different kinds of relationships. Now we're going to really dig into like once I have my data schema and I have data in there and I have it organized, how do I work with it? And that's what queries are. And then joins are a special kind of query that let us combine information between tables. So by the end of this, we're going to learn how to write SQL queries to get useful and interesting data. We're going to see how I can combine data from different queries together. For example, we have a bunch of car shop data here. I have different cars with ID, make, model, year, color, driver. Um, this car shop has different services that it provides, such as an oil change that costs $29.99. The cars get serviced, and here we see an example of a join table. So we see that the car with, the service with ID2 uh, was applied to car with ID2. So car with ID2 got a service. So this Ford F-150 got a brake inspection. And we will see how we can use join in our queries to find out, say, what services that Ford F-150 got and combine these different tables. And we'll see various SQL functions that let us aggregate and work with and manipulate data. And we're going to be working with this database of car services for our car store. And we see here we have license plates for our cars. Um, the car shop has different employees and some information about them as well. So first, I'm going to do a little bit of talking. We're going to see how we can work with data to get familiar with the database, and then we'll really dive deep into different ways of querying, right? We'll see a select query, aggregate functions, how to filter with the where clause, group by, alias, and columns. And then part two of the lecture will focus on joins. What we're also going to see is a little bit of DB setup, both for review and for useful things. We'll see how to import an existing SQL schema file into Draw SQL. And we'll just review the process of creating a Postgres DB from existing CSV files and SQL. And let's, in fact, let's tackle both of these. And all of this example code here is in the curriculum as well. So we have SQL for our car shop. And speaking of how to familiarize oneself with the database, whenever possible, you want the SQL code. And what's also really important is for anything important, don't run the SQL and pSQL directly. For anything important, always put the SQL in a file. This allows me to easily reproduce my work and allows other people on my team too. You don't want like a magic black box of a database that doesn't have any SQL files or queries and you have no idea how it was created. And we'll actually see they're called migration tools when we get into Django to help us manage database schemas. But as we go through this database schema, we see that we have a department table and we see a lot of the constraints that we learned about yesterday. Our serial primary key for the department ID, our department name, that's a var chart that can't be more than 50 letters. Department names have to be unique and they can't be null. And as you're reading through the SQL, it's a good habit to look at the actual data as well. And this will really help you get a sense of things. And in fact, let's do a little bit of a split here. And Up next, after our department table, we have employees. Employees have a salary. It can't be null. The salary has to be greater than zero for data integrity. Employees have a first name, a middle initial that's only one character, a last name, a department they belong to, which can be null. And then there's a foreign key to connect an employee to a department. And then we have a check that's written down here to make sure that the employee's middle initial either is null or of length one. And then we have our table of different services. And we have the name of the service and we have the price, where we also see some checks to make sure that the price is valid. We then have our different drivers. And again, we see here various checks. Here's a good one, making sure that the driver's age is a valid value for an age. Someone can't be -3 years old. We have our car, right? And we see here the foreign key connecting the car to the driver table so we can see what driver owns what car. We see cars have an ID, a make, a model, a year, and we have a check here. We've made a design decision that any years before the year 1900 are not valid. Cars have a color and a driver. Cars have license plates. And again, we have connected that license plate to the car with this foreign key, right? So the plate has a foreign key car ID that's declared here as a column. And here we turn that car ID column into a foreign key so that I can have a license plate and Postgres will know that this car ID value of 3 here connects the license plate to whatever car has that ID of key, that ID of 3. And then finally, we have a table named car_service. Excuse me, let's put that there. And let's go back to our SQL here. And the fact that this is named this way with these two tables indicates that this is a join table. And that this is a many-to-many relationship, right? And this was what we learned yesterday. We've seen with our foreign keys thus far, we've seen some one-to-one relationships and some one-to-many relationships. But now we're looking at an example of a many-to-many because a car might get a brake change and an oil change. And indeed, here I see car with ID2, got two different services. And many different cars can get brake changes and oil changes. So this is a many-to-many relationship. So as you're familiarizing yourself with a new database, whenever possible, if you have data like this to work with, that's a really good way to do it. What we can also do, that's great if you want a visual tool. With a real-world database, this might be less possible, but it's certainly worth a shot. One of the nice things about these visual tools is you can import SQL files. So we're going to give draw SQL a minute to load up, and we are going to do import. And a .ddl file can just be an SQL file that has all of the SQL for a given data schema. And if we just do a little bit of navigating to get to our file, fingers crossed, we should be able to successfully import this. And if we do run into an issue like with these copy from the CSV, then there's another way to tackle it, but it looks like this works just fine. And so now I have a diagram of my data model. I'm going to kind of move these things around a bit. I just want to move these around so it's a little easier for me to see. Let's put the car here. Let's put the plate here. Let's put the driver here. Let's put the service here. Let's put the car service here. We see that, in fact, this did not do a perfect job of connecting these things because it did not catch the many-to-many relationship between car and car service. So that just points out that these tools are imperfect, and this is why manually exploring your data is really important. And let's go ahead and connect these up. So car service keeps track of that a car with, say, ID 4 got, say, a brake service. And this is our many-to-many relationship in action. And then we have department. And for some reason, we may not actually have an employee table. So I thought we did. So we in fact do have an employee table. I don't know why that didn't got built out in our data model. So let's quickly make an employee table right now. And I'm going to keep it really simple. I'm not going to worry too much about the constraints. Let's just add the columns. So there's salary, and let's just add first name, and let's just add department ID, because that's the thing that we actually care about in terms of our diagram. And the department ID is the foreign key so that an employee can belong to a department. And an employee can only belong to one department, but a department can have many employees. And now we have a nice diagram of our data model. So our next step in terms of visualizing data is it'd be really nice if we can mess around with it in the actual database. So let's go ahead and actually create a database here. I'm going to go into pSQL, and I already am, but I'm going to make sure I'm in the directory that I want to be. I want to be down here in the command line. I want to be in the same directory as the SQL file I'm going to execute from there, and I know where the data directory is. Because if I look in this car shop SQL file and this copy command, I see all these relative paths, and it's expecting all of this to be executed with a relative pathing so that it's starting in the same place that the data directory is. So I'm making sure that I'm running pSQL from that spot before I get started. And I'm going to create a brand new database for this. And we'll call it car shop. And it turns out that I already made that. No problem. We will delete that database. And now let's go ahead and create an empty one. And now let's run this SQL. And now we have a bunch of things created. And let's talk through how to explore this data. You can actually add comments to SQL in Postgres so that it's stored in Postgres. If I use /d to look at all the different tables, we see all of our different tables and car ID and so on. And if I wanted to, I could say comment on schema car is, this is the car table. And let me correct this. And this would actually then be stored in Postgres. And unfortunately, I don't think it shows us the comments here. But we are able to look it up with various commands, like the one here. Let's see if we can get this right. And this is a little more advanced. And here we see the description of the car table. Postgres actually, under the hood, it stores things as objects in a sort of way. So you can actually do sophisticated things that like a more old school relational database can't, but that's a little bit out of scope. Really the important thing in terms of documentation is making sure that you put all of the SQL that creates your tables and everything in a file and that you have good comments. And same with any important queries. Um, we've looked at our foreign key relationships and we've reviewed our constraints. We did it by manually looking through the code. I can also do it if I don't have access to the SQL code. Oops, excuse me, let's get rid of that. I can do it by using pSQL commands. Again, I can look at all the different tables and I could look at, oh, I apologize. I need to actually connect to my car shop database. And now let's run that car shop SQL. And I was seeing all these tables I didn't expect to see. And it made me realize I had forgotten a step. And I think I just have one or two tweaks to make here because I was fixing some naming convention issues. I was changing in a couple places, we just have to change some of our table names to be singular and not plural. And that's what these errors here we were seeing. Relation services does not exist on line 82, and we just fixed that one. And we see the same thing on line 84, relation car service does not exist. And I think the issue there, so that one should work okay. So let's try running our SQL again. And I believe we should be good to go now. And if I do dash D, I see I've got my car table, my car service table, department, driver, employee, plate, service. And let's look at that car service table, just for example. So as we're exploring our database, we can use this dash D and then the name of the table we want to look at, and we can see our foreign keys and other things in Postgres. But again, all these other tools are really important to help us understand stuff. And then most of all, just looking at data, right? And exploring my data this way when I'm in the database. Um, Postgres does actually have an explain analyze command. Right now, our queries are pretty simple. So there's not a lot happening here. We see how long it took the query to run, 0.32 milliseconds. We see how long it took the Postgres database engine to plan how to execute the query to get this data, 0.68 milliseconds, and some additional metadata. And if I was to do a where clause where we're going to search for services for car number 1, we see it takes like 0.2 milliseconds longer to do this. It tells us the number of rows removed by the filter. So this can be a useful tool. It does get a bit in the weeds, but it's very cool to see that it exists. And especially as we start using joins and other things, it's very useful to have. And note that we didn't actually see the results of our query. So I do want to go ahead and let's just run it like that, and then we can see our results. And I just want to pause here and see what questions folks have. Tom, yes, sir.
Um, when you run backslash D, are you able to query by
One moment. I think I'm having an audio issue. Let me just hop back to my normal speaker with apologies to Alex here in the classroom. Okay, let's try that one more time, Tom.
check check? Can you hear me?
Yeah. Yeah,
Okay.
you're
So when you run backslash D to look at your tables, are you able to um, have it so that it only shows you your main tables and not your sequential tables?
that's a good question. I don't think so, but I could be wrong. I would actually have to look at the P-SQL docs for that. Um, Under the hood, when I do \d, note that it says lists of relations, and I basically Postgres considers all of these things different kinds of, I guess they call it relations. So there's a table, a sequence. We haven't really seen indexes, but so, and then there's a couple that are a bit more advanced, and that's why we see these all in one spot because they kind of interrelate to each other pretty tightly. Yeah, that's a good question. I'm not entirely sure. We would have to look sort of through their options here. We can see D lists tables, views, and sequences. It doesn't look like there's a filter option. It's something to show system objects and additional details. I'm honestly not sure what those do. Yeah, great question. Tony, yes, sir.
Yeah, I had a question about yesterday's assignment. Now that we're kind of on this, but so we had an issue where it was talking about the minimum income that an employee could have, but then when you do the math on it, some of the employees didn't meet that income threshold. Was that intentional, or is there a specific way that you would calculate salary given an hourly wage that would have made that data work? Essentially, if you did the math on it at 40 hours a week at 52 weeks, he would have made $2,000 less than the threshold. So,
I would have to look through the details of the assignment. However, there definitely were some gotchas thrown into that data on purpose.
okay.
Yeah, I will take a look on that one specifically, but you do raise a good point. Um, this data here is what we call clean. Everything makes sense and it's well organized and it all follows the rules. Real world data is very, very messy. Yeah. So it's quite possible that that was thrown in there on purpose because that's a great example of something you would run into all the time where somebody hired an intern and when we designed the database, we didn't think about interns. Which does
So,
touch on a good point. Like if we look at and just one moment, and then I know there's some follow-ups. If we look at this data schema here, for year, a car, the year of a particular kind of car has to be past the year 1900. For learning purposes, as we're learning SQL and learning about constraints, it's really good to be stricter because it forces us to think about our data. What you guys will find later as you get out into sort of like real world engineering situations is that data models tend to be very conservative because once you have real data in here, it becomes very hard to change. And because there's currently existing data and you can mess it up and other things depend on it. And so often you'll see like the core data model be more generous than you would think, but you have like code surrounding it that like with Python code that has a lot of those other constraints. And Tony, I think did you have a follow-up?
yeah, so I guess my question is best practice if you came across that in the industry, do you just lower the threshold for the minimum income knowing that that person's an employee and they make the mit or below the minimum income?
That's a great question. In the real world, if I'm a programmer and I have to add a new employee to the system and their income is below what the database allows as the minimum income, I'm probably going to have to talk to my boss and talk to someone else because that impacts a whole bunch of
Huh,
other parts of the business, right?
definitely. Okay.
Yeah, yeah, it's a great question. And again, that's why you'll often see like to sort of draw, let me draw a diagram here. So as like if you think about like a program or a system and we've got data going into it and let me make it let's make this blue. All right. And let's say this is like Python and let's say this is like more Python, but maybe this is our Python model definitions. And then finally all the way here in the center. Um, let me let me get it typed out here. There we go. We have our database here in the center, and it's like the center of the onion. Because all sorts of other code like depends on the database. Changing one thing here can impact a whole lot of things, right? And so basically, you want to try and make it so that you change the code at the center of the onion less, and stuff that might change more, like business logic around minimum salary, you would probably put in outer layers of your application. I realize that's a little bit off topic and it's not something we directly have to worry about right now, but it is very good to be thinking about because in the real world, like, there might be legal reasons why we don't want to change the minimum salary in the database that the whole company uses. Yeah, great question. Alex, yes, sir.
To uh sorry. Yeah, to build on top of Tony's example. Not example, we were actually going through this yesterday, and Tony, correct me if I'm wrong. When we were dealing with that specific check for the employee salary, I think when we would try to connect the SQL file to the database, because two of the employees were failing the check, I don't know if the rest of the employees were being put in. I think it was failing altogether. I don't know if
Um,
that does that make sense?
yeah, I think this one might be better tackled later
Got it.
when I can actually look at the assignment and we can look at your code. Yeah, remind me and we'll make sure to look at this one later today. Cool. Thank you guys. So I just want to make sure we have enough time to hit joins, and also I'm not gonna I'm gonna be way more effective in tackling this when we can actually like pull up the code and the assignment and look at it. Thank you. Um, so we're talking about sort of like exploring a database and data integrity, and it brought up a lot of good points. And I think what all this drives to is that data is modeling the real world, or it's modeling our imaginary world. Like if we had a role-playing game, data is modeling that world. And the more you kind of think about what the data is modeling and what it represents, the easier it's going to be to work with. Let's go ahead and let's start talking about querying. And this might touch on some of these things. I'm going to have this sort of pulled up as we do some querying through our code, but we'll sort of I'll be running it as well. And if we look at our car data here that we've imported, we can start writing select queries, and we can use the where operator. And in fact, let me just go ahead. Let's make a file. Let's call it queries. And let's actually look at that one. And then, so back here, I can run this. So we're going to look at the where clause. And where is used to filter results. And the way to build queries build them step by step, starting with more data, and then slowly adding filtering rules one at a time. So if I want all cars with year greater than 2020, I'm going to start with a query to get all cars. And let's just do select year. And let's do ID, right? So I can see the car ID. So let's select ID and year from car. And let me go ahead and run this SQL. And now I can see all the cars, and I can see all the IDs. And this is good because, sometimes there might be too much data to eyeball. But right now I can like already eyeball this and I see there's like one thing past 2020. So now that I have this working, I would add my filter where the column that I'm interested in, and now I can use all sorts of operators that we're used to from coding, like the greater than operator. And now if I run my query again, we see that in fact there are 3 cars and my eyeballing was totally wrong. And we have 3 cars with the year greater than 2020. Often you will write, you'll see queries written like this. Especially as they get more complex, it can be useful to put the where part of the clause on a separate line. It's really personal preference. So I can do greater than. There's also greater than or equal to, like in this second example. Or excuse me, this second example is equal. So I want cars whose price is $29.99, right? So let's do select ID and price from car. And let's just start there. And actually, if I look here, I see that we have a goof in our code. And in fact, there is no price value for this car. So I'll update the curriculum, but let's just play around more with year. So, and again, with real world data, this is not uncommon. So let's search for cars whose year is 2018, right? And again, we'd build that query. And I'm going to rename this file real quick to just query.sql so I have less to type. And I see all these years. And now I add my where clause where year equals 2018. If I want to see years less than, but including 2018, I can just do less than or equal to. And if I want to see, if we look at our car data, let's say I want to see all the, man, we only have one of each, but let's look at all the Nissans. And we'll see how to work with strings more later. But just to kind of get the ball rolling, let's do select ID and make. And just for fun, let's look at the year as well from cars where the maker is Nissan. And again, you can write this directly in pSQL, and this is a great way to do it when you just want to explore your data. But as you can see, if you need to be really working on and modifying a query, it's easier to put it in a file. And I just want to pause and see if folks have questions or stuff that we're curious about. Cool. And if we take a quick look at the Postgres docs, and we look at this where clause, because it is extremely powerful. we'll see that there's a lot of information here, right? And in fact, we have a whole breakdown here on queries. And I actually would recommend just giving this whole chapter a read because it's not too long and it breaks it down, right? And a query retrieves data from our database and it retrieves rows of data, as we can see here. And in fact, if we use, let's go back to this query that we were doing, and let's just do explain, analyze. And we see that, again, part of what a query does is it happens in stages. Postgres actually gets all of the rows from the table, and then it applies that where filter, and it shows us how many rows it removes with that where clause or that where filter if we use the analyze command. So we see here a query syntax. Postgres breaks it down. Star will give me all the columns. If I want a particular column, I can say that, give their specific names. I can do some fancier manipulations that you really have to do in here. You can do all sorts of things inside select statements. This is a good point. Select is sort of a very flexible tool. Like I actually can do math in there. Um, and this gets more advanced and we don't need to worry about this so much. But this is how you can start to do really fancy things in SQL queries. Though most of the time these days, stuff like this, if we really needed to do it, we would do it in Python. So we can see here the from clause broken down. We're not going to worry about joins because we'll talk about joins later. But let's just take a quick look at the where clause, which is what we've been exploring. And so we give this, it's basically like an if else statement, right? Where we're searching for something and it's sort of applying a Boolean. And we see a number of examples here. And actually, here's a great example. I can actually combine multiple statements in my where clause. And let's look at our car data and let's look maybe for all of the blue cars that are greater than year 2019. So I think that will give me one car. And let's build that query. I want all blue cars after year 2019. And again, the way to do this is step by step. Right? So I'm just going to go ahead and I'm going to run my query. And I'm going to add the filtering one step at a time. Where year is greater than 2019. So let's start with that and make sure that that works. And that's looking good. And now let's add the second part of our where clause. And this is very much like if statements. And color equals blue. Now, we don't see any data here, and this is a little surprising. And that's because just using it, a simple sort of string comparison is case sensitive. And this is one of the biggest gotchas. We'll see how to tackle this later. And now when I have that correct case sensitive string, you see our one blue car with the and. Right, so this is definitely worth a bit of a read. I think going through the Postgres docs on where we'll see some of these more advanced things a bit later. But I want to kind of move on and look at some other built-in functions that Postgres has. And I do want to just check in and see if folks have questions or are curious about stuff before we keep on rolling. Tom, yes, sir.
Sorry, had it a while ago. Oh, that's what it was. When we query data, obviously it's because we want the data most likely for a display purpose or to do something with it. Um, to display it to the front end or manipulate it with our program, etc. but can we also utilize these queries to populate uh, columns and rows for tables as well?
Yeah, you absolutely can.
Oh,
You can do what's called subqueries, where you could like use a select statement to get some data and then put that into an insert statement to put that data into a table. Postgres even has something called views, which is sort of like, if I do like x equals 5 and then I say y equals x, y is sort of like an alias for x. You can like create a temporary table called a view that's built off of a query, and that gets used a lot of the time as well. That stuff is out of scope, but you can do honestly all sorts of pretty awesome things with SQL.
okay.
Yeah, great question. Yeah, subqueries and views would be the key terms to look up. SQL also has a lot of really good built-in functions, and this is sort of the SQL language standard, right? And so here's an example of counting, right? And I just want total number of cars. So let's do select count from car, and let's run this and see what we get. And what I need to put in here is the columns that count is going to count up. So I could do ID and it would work just fine. I could do year. I could do anything I wanted. The one thing I would want to avoid is if I want to get the count of all the rows, if something had an optional field, like if color was optional, then count might skip something. So often you see count ID or count star. Alex, yes, sir.
Right there in this scenario, is this assuming that maybe the car table ID isn't serial? Wouldn't serial sort of do this for you?
Yeah, that's a great question. So you touch on a good point, right? I have here in my data, let's just do select star from cars, from car. Well, I can look at this ID and I've got 10 cars. What though if we remove a customer and we do delete from car where ID equals 5? Um, and I mean, just a sec here. SQL delete row. I gotta remind myself of my syntax here. So I think that should be correct. Oh, because it's depending on plate. So we're running into some cascading issues here. Um, because license plate has a foreign key that relies on cars. Let's try adding cascade at the end of this and see if that does the trick. Um, yeah, I can't just add it in. So let's use a different example. Let's use the license plates because this one I should be able to delete easily. And if let's in fact go look at our license plate and we see it has a foreign key, but I don't think anything depends on it. So I've got my I've got my license plates, right? And I can see from the ID that there's 10 license plates. If I do select count star from plate, gives me 10. Why is this special? Well, what if I do delete from plate where ID equals 8? So now I've successfully deleted a license plate, right? And let's confirm that. And we can see that there's now 9 rows of data. So now if I do select count from plate, I see that there's 9. Right. So the ID auto increments, but data is changing all the time. And once I delete something, Postgres is not going in there and updating all those ID values because an ID column's job is to uniquely identify a row. If I'm constantly changing it, that's going to be a pain.
Got it. Thank you.
Yeah, great question. Right? Because up until now, like we've really been able to rely on IDs always being consistent and always being in the same order. But again, in the real world, data is always changing and it's messy. Yeah, great question. Um, and let's in fact add those examples here. So let's show deleting a license plate and then getting the count. So we would say delete from plate where ID equals 8 and select count plate. And now if I run my queries just as a sanity check, we see that. And let me go ahead and rerun the car shop SQL to reload all that data so that it's all back in there. And now if I do select star from plate, we've got 10 plates just so it doesn't mess anything up. We'll see this alias later, but we can use as will make an alias or the column name. So I could do select count as total cars from car. And if I run this, I see that all that's changed here is this column name. But if I'm building a more complex query, this can make it easy to refer to this column as I'm doing other things. Or if I'm building a report, it can make it easy for the person reading the report to see what this means. So we've seen count. We also have sum as well here, as we can see, where I can add stuff up. And here, in fact, we see as in action. And so I could do select sum, and we don't have car prices. Oh, this is adding from our service. Perfect. So we can do this. So let's call this cost of like total service from service. If someone wants to get the full treatment, then it would cost them $129.99, right? Cost if a customer wants to get all the services. So again, this is where we can start to see how the data starts to get useful in the real world. Or same with this example. If I want to figure out like total salary cost. Well, again, remember, I want to start by building up a query as simply as possible. So let's just do select salary from employees, from employee. And we see the different employee salaries. Once I know that my basic query is working, now let's add in our aggregation function with sum. And let's say as, total salary cost, right? So if I want to see as an employer, how much do I have to spend on salaries annually, then this is the way to do it. In fact, let's call this annual salary cost. So there's also an average function if I want to figure out the average service. So this is a good example. What's the average cost of a service? Well, let's do select average price as average price from service. What's the average salary of my employees? And again, as my data changes, this becomes really useful. and we see the average salary. So those are a bunch of Postgres's aggregate functions. And again, if we kind of search for, I think it's like Postgres um, aggregate functions, we'll see here that Postgres has a lot. If we give the browser a second to load, why the Postgres docs are going so slow, I don't know. Let's see if we can look up here real quick. Uh, Rick, yes, sir.
Yeah, I was just gonna say that yeah, all these functions are really cool. I don't know if it's a function that we may have already gone over, but not yesterday, but the day before, I was looking at a function called triggers, where you can actually set uh, triggers. You can even set a trigger to update a field of user that changed the data, timestamp on when the data was last changed. If you were using a database for ordering supplies, you could set a trigger with a threshold that if a value is below a certain amount, then it adds 10 to another table, like ordering more supplies, that kind of thing. So.
Yeah, totally. Yeah, there's a deep well of interesting and useful Postgres functions. Let's go ahead and let's take five, and then we will dive into the where clause, and we'll see how we can start combine. We can flesh out the where clause, and we'll add in some more complexities with where in, and also doing some filtering and limiting. Thank you guys, and I'll see everyone in 5 minutes. All right. So we've covered setting up a database. We've seen that we can import our data model into here nicely. We can also do a data dump. By the way, if you ever want to dump data from Postgres, um, on the command line, if I do pg dump the name of my database and then use the command line pipe operator, let's put it into car shop schema.sql. Postgres will look at that database and all of its settings and dump it into an SQL file. And this is one good way to back up a data schema and share this. And you could check this into version control or import it into draw SQL or what have you. And then you can, of course, load it back in. We won't need to do this, but this is useful to see. So we've gone through that. We've looked at select queries. We've looked at aggregate functions. We got a brief preview of the where clause, and that's what we're about to dive into now. We did talk about aliasing a bit, and we're going to look at where clause and group by, and that'll really cover kind of part one of queries, and part two will be a deep dive into joins. So let's look more at the where clause and talk about filtering, because this is where it starts to get fun, no pun intended. So, and let me hop back to P-SQL here. So the whole point of the where clause is when I make a query, actually, let's talk about this for a sec. When I make a query, it sort of builds a temporary table. That's kind of what's going under the hood in Postgres. A query is sort of a temporary table, and we have these result rows. And that's the first thing that Postgres does. If I add a filter with the where clause, it sort of runs that first part of the query and then filters that table. And now this is my temporary table in my result row, right? And we've seen a couple examples of filtering. So I want to get all the Hondas, or maybe I want to get all employees making over, well, let's take a quick look at our employee data. Making over 55K, let's say. Making at or over 55,000, right? And I could say select, and let's actually grab our employees by name, and they have a first name and last name. So let's select first name, um, and let's just call this employee name from employee, where salary is greater than or equal to 55,000. And fingers crossed, I can now run this query and we'll see those employees. And it doesn't like the comma with numbers, so I do have to be mindful of that. And I can see my employee first name. I could actually do a little concatenation here if I wanted. I believe there's a concat. Let's actually look this one up. And this is really what I want to do here. And it looks like the concatenation operator is the two vertical pipes. There is indeed a concat function, as I kind of suspected, because this is such a useful thing. So if I want to see my employee and I want their full name, and we've got first name, middle initial, and last name, and I want to put this all together, I might say select concat first name, let's add a space, let's add a middle initial, let's add another space, and let's add a last name. And let's call this full name. And at this point, this is a whole lot of typing. So I think, and in fact, I realized I forgot this here. So I think what I'm going to do is I'm going to actually put this from on another line. And sometimes you'll see queries written like this. You might even see different fields written like this. And I might have a typo here. I might need a comma. I might not. Let's run this and see how we do. And the programming gods were with us, and I had no typos, and we were good to go. And again, the way to build a query like this is in steps, right? And if I was to build this step by step, I would have pSQL open, and first I'd do select star from employee. Then I would do select star from employee, where salary is greater than or equal to 55,000. Now at this point, I can start messing around with which columns I want to return and concat, and I know that the core of my query already works. So that's the where clause in action. And you can combine multiple where clauses together. If for some reason I wanted to run this same query, but I only wanted employees whose middle initial is A, then I would just add an and to my where clause. And in fact, maybe I want to sort of write my query a bit more like this. And this is often how you'll see this written. And it looks like there is no employee with middle initial A. There must be. So why aren't they showing up here? Well, what's happening here is first I do this select from to get all the employees, but I'm only getting this sort of combined full name and this salary column. Middle initial isn't in one of these columns that I'm getting. And so in fact, let's go ahead and also get their middle initial. And I clearly have something wrong here. So let's debug this query step by step. Let's see if we can get an employee whose middle initial is A. And the problem was with my assumptions. John Doe is not making 50,000, 55. He's making 50. So let's change this to where salary is 50,000 and middle initial is A. And we need to add our comma back. This is the danger of refactoring, right? You can get a little lost in the sauce. And I wonder now actually if middle initial was even needed. Yeah, so I apologize. I got a little confused there and I jumped to conclusions about what the problem was. So this does work just fine. The problem was that there actually is no one who makes over 55,000 and has a middle initial of A. We will see this issue come up when we get to group by in just a little bit. This does touch on some challenges with string manipulation, and this is where the like operator in Postgres starts to become really useful. And this kind of falls under the category of pattern matching. And we saw before you can use straight up regex, but Postgres gives us some really nice helper functions. So I can use like to sort of compare strings. I can do not like, and we see some examples here where we can do an exact string comparison. This percent sign is sort of a placeholder for everything else. So we're saying, is ABC like a string that starts with A and then has other stuff after it? Is ABC like a string that has B right in the middle, right? So we're actually checking the number of characters. But then here, this exact comparison fails. And so what we often might see is let's go ahead and modify this query. And forgive my jumping around here. And let's try to use like to say and full name like. And this isn't going to quite do the same thing, but we're going to check if there's an uppercase A somewhere in there. And here we run into some problems with using our alias. This column doesn't actually exist. And so here I run into issues. So I can't really do this the way that I would want. And in fact, I think probably the simpler example here is a good starting point with using services. And if we search for name of service like break, and let's take a quick look at our service names. So we have break inspection, and this is really the only one that's going to come back. We see nothing, right? Because right now we're doing an exact comparison. And if I put a percent sign at the front of this, we're still not going to see anything because the string is starts with break. So if I do it like this, it will check for a name of service that starts with break. And so then that works, right? And so what you'll often see is check if string contains, where we use 2% signs. And we see the two queries that both return break inspection. Now, the problem with break is the problem with like, excuse me, is case sensitivity. Like is case sensitive, and this can be a pain because I don't want to have to always remember to use my uppercase correctly when I'm searching through strings. So that will fail. But if I change this from like to I like, and I think I there stands for insensitive as in case insensitive, then we see that that works. Um, let me go ahead and talk about in, and then I think that might be we might be getting close to a good plus point. So in is pretty interesting. You can give it a list of basically allowed values. So maybe I want to find all the Toyotas and Hondas, right? So let's build this query out in my car table. So let's start with select star from car. So far, so good. Let's now try one of these filters. Select star from car where make equals Toyota. So far, so good. I can change it to Honda. So far, so good. But if I want Toyotas and Hondas, this is where I need to use the in operator. And I can say make in Honda, Toyota. I can give it a list of values. And as long as the type of these values is the same as the column type, then I'm good to go, right? Make is a string type, and these are strings. So fingers crossed, this should work just fine. And now I can see the Toyotas and the Hondas. And then the example here is, let's say I want to see specific services, right? Find specific services by ID, where I might say select name of service from service where ID in 2, 4, and 6. And if we go ahead and run this code, we see that we have the brake inspection service. And let's take a look at our service IDs. And we see we really only have 3, and some of these don't exist. So if these don't exist, they just don't show up. Let's throw 1 in just for fun so we can see a little bit more. And so now it finds the 2 services that are in that list. Alex, yes, sir.
Is in integer based, I guess. So does two things. After where, the ID, can it be a different column, like driver or something? And then you use the in, and then that list that you create, can those be strings?
If I understand your question, do you mean like,
Oh my God. Never mind. Sorry.
yeah,
Taking
no,
notes.
all good, all good. Um, yeah, and I mean, it's easy to get confused, right? I got confused before about like, do I need to have the column names here for where to use? And I don't. Like, I could say color, right? If I just want to see the colors of the Toyotas and the Hondas. Um, and of course, you can combine queries, right? And year greater than 2018. And let's just see year, color. just for fun for our query here. And the combining is where it really starts to get interesting. As we've talked about and we've seen for aliasing columns, um, and Alex, during the break, you touched on a couple good points. If I use as in query, it doesn't change my data model. It's sort of in this temporary table that's created for my results, just gives this column a different name, which is useful maybe if I'm building a report. And as queries get more complex, sometimes it does come up where you might need to use the column alias. Um, Average, we saw in action already, I believe, when we looked at average salary. Um, like we've been exploring and playing around with, and we've seen the different options here. Um, and now let's talk about limit and descending or ascending. And these are quite useful. And they usually get used together. So let's talk about limit, descending, and ascending. And let's say I want to find my highest paid employee. How would I do this? Well, I know that I can search for all of my employees, right? And maybe I just want first name and salary. Now it just so happens, probably based on some default values in Postgres, that these results, well, these are actually ordered from, it might be lowest salary to highest. I'm actually not sure how Postgres is organizing it, and I actually haven't told it. So first thing I need to do is I need to order these results by salary. And let me go ahead and grab this and let's put it in our query file. Right? So we have a select and we have a from. And now I want to say order by salary. But I don't want it in increasing order. I want it in decreasing order or descending order. And now I have all of my employees ordered by salary descending, but I only want the highest paid one. So we are going to add a limit. And now when I run this query, I get my highest paid employee. Right. And so you can combine the order by descending or ascending and limit together actually for really powerful results. Alex, yes, sir.
What would take precedence if you use select count, uh, uh, and then the limit?
Yeah, that's a great question. Using the aggregate functions like count can start to get a little weird if we're using order by limit. And let's actually see what happens here because I'm not exactly sure what would happen. And what we see here, this error message must appear in group by. We're going to see group by in a little bit, but basically, if I'm counting something, I have to have a group of something to count, right? And if I'm limiting it to like one result, then it kind of freaks out and doesn't know what to do. And in fact, probably even from here, it freaks out and doesn't know what to do because whose first name do I show next to the salary count? And here it still freaks out and doesn't know what to do. And if I
Got it.
just break it down like this, well, Now the count I'm getting is really just the result rows. Um, let's see if we add limit 1, we still see count is 3 because this limit is about the number of result rows that we see, and we're just seeing one
Oh,
count row. Yeah,
got it. Okay, this makes sense.
yeah, yeah, that's a great question. Um, yeah, so you have to be a little careful in using the aggregation functions, and actually in just a minute we'll see this with group by. So and you can see some other examples here for limit, and let's just go ahead and run some of these just so we can see them in action. So here I can see just 5 of my cars, right? So if I'm building pagination, this can be useful. Um, you know, maybe I want select from car order by year, and I want to see, for some reason, I want to see the oldest cars first. And so now I've got my 5 oldest cars. And let me get rid of this count from salary here. So order and limit by are really powerful, right? And we can order by ascending and descending. Before I dive into group by, I do want to pause and just see if folks have any questions about stuff. Okay, awesome. Let's take a look at group by, and then we'll take a longer break for part 2 for the joins, because that's when it gets interesting. So group by is where things start to get interesting, as we just kind of saw a preview of. So if I wanted to count all of the cars by make, now I don't actually have many different makes of cars. If I do like select star from car, I think we're just going to see one of each. There's Hyundai, there's Jeep, there's Ford. If I look at colors, here's where we do have a couple duplicate colors. So let's focus on colors. Let's say I want to find out how many cars of each color have. Well, one would think I might be able to do something like select color count color as car count from car. But we're going to run into a problem here. And we see again this error that says must appear in group by clause and so on. And again, the problem is how does it figure out when I'm counting up colors, which color goes next to each one? I need to tell Postgres that I want Postgres to group and organize my rows, right? Postgres can't just figure that out on its own. So I need to say select from car, group by color. And it's important that I'm grouping by the thing I'm counting or aggregating, right? And now I should be able to see how many cars of each color I have. And so now we can see I've got 2 red cars, 2 blue cars, and 1 of everything else. So this is super valuable, and this is important, right? If I changed this to group by year, we would see that same error, right? Column car color must appear in the group by clause. All right, so with group by, when using aggregate functions to count, get average of, etc., for one column of my results, I must use group by on that column. So Postgres knows to organize the rows in groups based on that column, such as knowing to organize result rows by color to count number of cars of each color. Right, and I can still add my other clauses, like here's group by color. Let's maybe do order by car count descending. And if I wanted to, I could even say like limit 3. And so now I see the 3 colors that have the most cars. So again, it's once you start combining these different sort of clauses that things start to get really powerful. So let's take a look at a more advanced example of group by. And here's where we see the L for language in structured query language really come into its own, because we're actually going to see a case switch statement here. So what I can actually do is, if we look at our services, and I want to look at my services by their price range, I want to organize my services into low, medium, and high price ranges. So I need to group those services, and we're going to need to kind of come up with our own groups. And we're actually going to use a case statement to do this. So if the price of a service is less than $30, then we're creating a group called low. Right? And let's just maybe put this here. And we'll say when price is less than $50, then it's medium. And this is happening in order, right? So first we're going to check here, then we're going to check here. Otherwise, we'll say high. And let's just say end, and we'll call it as price range. And you can write this out a lot of different ways. This is a bit overkill, but I think it can help a bit to kind of see how things are organized. So I'm constructing a pretty fancy aliased column and a grouping here. And now I'm going to do group by this price range that I've created. And let's go ahead and run our query. And it looks like I have a typo, syntax at or near here. And I suspect the issue, maybe I totally forgot to add a comma. Let's try adding that comma after the else and see if that solves the problem. And let's in fact search the docs for this, because my guess is I may just have a syntax error here.
Price range shouldn't be in quotation, should they?
Oh, you may be correct. I think you are correct, Tom. That's an excellent point. Let's try that out. And in fact, in the demo code, it's not in quotes either, because I'm creating a column name. And in fact, VS Code is changing its colors. The strings are orange. The column names are white. Let's see if that does it. And let's get rid of that. Yeah. So excellent call, Tom. I think that indeed was the issue. There's now 2 things I want to do here. We're seeing results here. We're seeing high and low. Let's change this to high. But I'm not seeing another column. I did all this work to sort of create my price range column, but I forgot to do my aggregation and my counting. So let's do count star as number of services. And let's run this again and see how we do. And now we see the number of services in the high price range, in the low price range. I have something wrong with my logic here because I've got 4 services. No, I only have 3. I apologize. So actually, that's correct because one service is, let's put the query here and let's just do select star from service. So one service is below $30. One service is also below $30. So I have 2 low services and I have 1 really high service. So let's in fact make anything below $20 low and below $40 medium, and otherwise it's high. And now I should see like a nice even distribution, right? And again, to print out the services so we can kind of verify that our query is correct. This oil change falls into that medium range. The brake inspection falls into the low range, and the engine tune-up falls into the high range. So this is a great example of using a sort of more complex grouping scenario. Um, we do note that it becomes harder to see the name of the service, right? If I wanted that, I would actually need a subquery and it starts to get a bit complicated. And so on a practical level, maybe I just execute 2 separate queries. And then we have another example here of this case where we're looking at the drivers and we're grouping them by age, where I'm using case to create groups for driver age ranges from young, middle age to senior. We're counting the number of drivers in each group, and then we're grouping aggregating. Alex, yes, sir.
Uh, can you go over this end again? End as? Is this necessary whenever you do a case?
Yeah, great question. The end is necessary. The as is not, because I need to start my case statement, put each of my different cases or groups within it, and then end the case statement. And the only problem here, actually, and so in some ways, the as sort of is necessary when I'm saying group by over here. What result column do I want to group by? Well,
It doesn't know.
yeah, it doesn't know. It doesn't know. If I say price, it's probably gonna freak out. We can run this query and see what Postgres does, but it's probably gonna throw an error. So that actually does seem to work. It's grouping by it's grouping by price, but I in fact worry a bit that the behavior might be a bit different. I only have 3 services in here. Um, so I think a good practice, we do see group by age group here happening in the driver's age range. So I don't think we need the as actually, but it does make it more readable. Let me see, we can say end as we call this price range. And note that it just names that column case by default. And I always am adding single quotes around my column names, which Postgres does not like. Yeah, so that's a great question. We don't need the as, and our group by just has to be the column that we want to aggregate over or group by, which in this case is price, but it can improve readability to use aliases. Yeah, great question. All right, so we've covered a lot of ground here. I think this is a good time to pause before we dive into joins. We've hit database setup, we've hit select, we've seen a lot of aggregation, where's, group bys, and as. With joins, we'll see how to get data from multiple tables and combine them together using foreign keys. And then most of all, in queries, we've seen how it becomes really powerful to combine different things together, like order by and descending and limit if I want to find my highest paid employee, right? And this is part of the power of SQL is if I was writing Python, I might have to do a bit more work, but SQL is designed specifically for querying relational data that's organized this way. So let's take a break, and then when we come back, we'll see how to get data across tables. And let me go ahead here and stop our recording.